On July 19, 2024, a single 40-kilobyte file crashed 8.5 million Windows machines in 78 minutes. Airport check-in counters, hospital terminals, bank branches, supermarket tills, TV studios, mid-broadcast. All of them blew at the same time. It wasn't a cyber attack. Nobody hacked anything. Every one of those machines crashed because it did exactly what it was configured to do. The file that did it wasn't even a program. It was a configuration update. A few kilobytes of detection rules, pushed from the cloud, straight into the Windows kernel. And here's the detail that makes this story worth 25 minutes of your life. The actual bug had been sitting on those machines for 5 months. Fully deployed, armed, invisible. The July update didn't install the flaw. It just found it. By the end, you'll know exactly how one unread field in one config file put the modern world into safe mode, and why your own pipeline probably has the same shape of hole in it. Start the clock at 4:09 a.m. Universal Time, Friday, July 19th, 2024. In Austin, Texas, it's a few minutes past 11 on Thursday night. A cybersecurity company called CrowdStrike pushes a routine update to its Falcon platform. The kind of push they do many times a week. No press release. No maintenance window. Routine. Nobody in that building is nervous. Why would they be? The same pipeline has shipped thousands of these updates. The dashboards are green. The tests are green. Everything is always green, right up until it isn't. CrowdStrike protects a huge slice of the world's serious computers. Banks, airlines, hospitals, governments. More than half of the Fortune 500 run its software. Within minutes, machines on every continent start going down. Not one company, not one country, everywhere at once. And almost nobody knows why. So the first question, the one cable news never really answered. What is this software, and why does a config file have the power to kill Windows? The product is called an EDR, Endpoint Detection and Response. Think of it as a security camera for a computer, pointed at everything. Old-school antivirus checked files against a list of known bad guys. EDR watches behavior. Every process launch. Every file touch. Every network connection. Every whisper between programs. Because modern attacks don't look like files anymore. They look like actions. A legitimate tool, used at 3 a.m. by an account that's never used it, to read memory it's never read. Only behavior gives that away. And to watch everything, it can't live where normal apps live. Normal apps sit in user space, in a padded room. The operating system can kill them anytime, and the machine shrugs. Falcon's sensor lives lower, in kernel space, the same floor as Windows itself. There's a driver, csagent.sys, loaded during boot, running with the highest privileges a program can have. It sees everything because it stands next to everything. That position is the whole product. Malware can hide from an app. It's very hard to hide from the kernel. Picture the alternative. Ransomware lands on a laptop, kills the antivirus process, then encrypts the disk at leisure. That trick works on software the operating system can push around. It doesn't work on Falcon because the sensor is loaded so deep that killing it means killing Windows. The protection and the operating system share a bloodstream. Why does Microsoft even allow that? Partly history, partly regulation. Microsoft has pointed to a 2009 agreement with European regulators. Security vendors get the same low-level access to Windows that Microsoft's own security products enjoy. So kernel access isn't a hack. It's the standard architecture of the entire endpoint security industry. CrowdStrike and its competitors all live down there. But kernel space has one rule, and Windows enforces it without mercy. In user space, if a program touches memory it doesn't own, that program dies. Alone. In kernel space, if a driver touches memory it doesn't own, Windows can't trust anything anymore. Not the file system, not your data. So it does the only safe thing left. It stops the world. That's what a blue screen actually is. Not a tantrum, a controlled crash landing, to protect your data from a driver gone wrong. Hold on to that. A kernel driver doesn't get bugs the way an app gets bugs. Every mistake it makes is a potential blue screen by design. Now, how does a security camera learn to spot new threats? Attackers invent new tricks every day. Rewriting a kernel driver for every trick would take months of testing. Far too slow. That's why Falcon splits itself in two. The sensor, the heavy machinery, the compiled code. Updated a few times a year, tested to death. And the content, the knowledge. Detection rules that tell the sensor what suspicious looks like today. Small files, pushed from the cloud, sometimes several times a day. CrowdStrike calls them channel files. Each one numbered, each one feeding a different subsystem of the sensor. It's honestly a clever design. The dangerous code changes slowly and carefully. The fast-moving stuff is just data. And data can't crash a kernel, right? Well, data can't crash a kernel until the code that reads the data has a hole in it. In February 2024, 5 months before the blue screens, CrowdStrike shipped a sensor with exactly that kind of hole. Nobody would notice for 150 days. Here's the thing about that February release. Sensor version 7.11 wasn't reckless. It went through the slow lane. Sensor code gets the full treatment. QA cycles, dogfooding on CrowdStrike's own machines, early adopter customers, staged rollout. Customers can even pin older sensor versions. Careful by design. The new sensor added a fresh capability, watching interprocess communication, named pipes. The quiet channels programs used to talk to each other on the same machine. Attackers love them. To use the new capability, the sensor defined a template, a form with input fields. Match field 1 against this. Match field 2 against that. The template type lived in the sensor. The template instances, the actual detection rules, would arrive later as content. In channel file 291. Think about what that split means. The form was printed in February, in the slow lane, and burned into the sensor. The entries filling that form would arrive through the fast lane for years. CrowdStrike calls that fast lane rapid response content. It exists for a good reason. When a new attack technique appears in the wild, customers want protection in hours, not in the next quarterly release. The first rules for the new template shipped on March 5, 2024. After a stress test that passed, more followed in April. All quiet, all green. And that's the moment two lanes crossed, because the form and the rules that fill it were now maintained by different pipelines, different schedules, different tests. Let me show you the mismatch. It's small enough to slide through a code review and big enough to stop airports. The new template type was defined with 21 input fields. 21 slots a detection rule could match against. But the sensor code that fills those slots, the integration layer that gathers the live data and hands it over, supplied only 20. 21 expected, 20 provided, an off by one, sitting between two components that were written against the same spec. How does a 21 meet a 20 in the first place? Simple. The template type and the integration code were written by people working from the same design at different layers at different times. One layer implemented the promise. The other implemented the delivery. And no automated check ever held the two numbers side by side. Here's where it gets uncomfortable. There was a validator. Every channel file passes through a content validator before release. A gatekeeper built for exactly this. But the validator checked rules against the spec, 21 fields, not against the sensor as actually built, 20. The gatekeeper had the same wrong number in its head. But here's the part that should worry you. That mismatch is a loaded gun, and for 5 months, nothing pulled the trigger. Why not? Because of a wildcard. Every single rule shipped for this template, from March through April, matched the 21st field against anything at all. And a rules engine is lazy, in the technical sense. If a field matches anything, why read it? The 21st slot was never touched. Not once. Let that sink in. The only thing standing between the world and a global outage was, effectively, one wildcard character. The March 5th release, fine. April 8th, fine. April 24th, fine. Every test passed. Every stress test passed. Production stayed quiet. Not because the system was correct, because the broken path had never been walked. This is the scariest kind of bug, the one that passes every test you thought to write and waits patiently for the input you didn't think to send. And every one of those clean releases became evidence. Confidence grew. The content lane felt safe. That's not negligence. That's just how humans read silence. Somewhere in your infrastructure, right now, there's a field nobody has ever read, a branch nobody has ever taken. It passes every test too. On July 19th, someone finally wrote a rule that used field 21. 4:09 a.m. Universal Time Coordinated. 2 new template instances go out in channel file 291. One of them matches the 21st field against a real value. No wildcard. The content validator inspects it. 21 fields? The spec says 21 fields exist. Approved. The file replicates across the cloud, and Falcon sensors around the planet start pulling it down. Online machines have it within minutes. Each sensor loads the new rules and waits for the next interprocess event. Somewhere, a named pipe opens. A completely normal Windows heartbeat. The rules engine steps through its fields. 1, 2, 10, 20, 21. The engine asks for input number 21 from an array that holds 20. In user space, that's a crash report. In kernel space, it's a verdict. The read runs past the end of the array into memory that doesn't belong to it. Windows catches a kernel driver touching forbidden ground and stops the world. Blue screen on every machine that loaded the file and then saw a named pipe event, which is to say, essentially every machine that loaded the file. Now comes the twist that separates this from every ordinary bad deploy. The crash isn't the disaster. The loop is. Falcon's driver is a boot start driver. It loads early, before the network is fully awake. On purpose, malware shouldn't get a head start while the machine boots. So the machine restarts, exactly like the blue screen promised. Windows begins loading. Falcon loads with it, first in line. It reads its channel files, including 291. Named pipe event, field 21, crash, restart, load, crash, restart, load, crash. See the trap? The fix is trivial. Delete one file. And CrowdStrike moved fast. The update was identified and reverted at 5:27 a.m., 78 minutes after the push. But a reverted update only helps machines that can reach the cloud to hear about it. And these machines were dying before their network stack finished waking up. The cure existed. The patients couldn't swallow it. There was one absurd loophole. Between the boot starting and the crash landing, a machine had a few seconds of network. Sometimes, just sometimes, it fetched the fixed file in that gap. Which is how one of Microsoft's first official workarounds came to include a sentence for the ages: try rebooting. Up to 15 times. The most advanced company on Earth, recommending a slot machine. The only reliable fix, a human, at the keyboard of every affected machine. Boot into safe mode. Find the CrowdStrike directory. Delete the file whose name starts with C, dash, and a string of zeros ending in 291. Reboot. Why does safe mode work when normal boot doesn't? Because safe mode loads only the bare minimum of drivers. Falcon's sensor stays on the bench, and with the sensor asleep, the poisoned file is just bytes on a disk. A couple of minutes per machine, if the machine is in front of you. Now do it 8.5 million times. And a lot of those machines were not in front of anyone. Point-of-sale terminals inside locked kiosks. Servers and racks 3 time zones away. Digital signs bolted to ceilings, blinking blue at travelers below. And one more twist of the knife. Safe mode on a corporate laptop often demands a BitLocker recovery key. Guess where thousands of companies stored their BitLocker keys? On servers that were also running Falcon. The keys to the ward were locked inside the ward. Sunrise moves west across the planet, and the Friday morning shift walks into the same scene on every continent. Airports first. They never sleep. Check-in systems down at major carriers across 3 continents. Boarding passes handwritten in Delhi and Berlin. Departure boards frozen or blue. In the United States, the Big Three, Delta, United, American, asked the FAA for a ground stop. For a few hours that Friday morning, they simply stopped flying. In Atlanta, Delta's crew scheduling system, the software that knows which pilot is legal to fly which plane, goes dark with everything else. Hospitals postpone non-urgent procedures. Pharmacies can't pull up prescriptions. In several U.S. states, 911 dispatch lines wobble. Sky News, in Britain, drops off the air mid-morning. A broadcaster silenced by a security agent doing its job too literally. The timing added its own pressure. The Paris Olympics were 1 week away, and organizers spent the day checking accreditation and ticketing systems against the outage. Microsoft would later estimate 8.5 million Windows devices went down, less than 1% of the global Windows fleet. It did not feel like 1%. Why did 1% feel like the end of the world? Because it wasn't a random 1%. CrowdStrike sells to the organizations that can afford the best: airlines, banks, hospitals, exchanges, governments, the backbone percent. Your cousin's gaming PC was fine that morning. The machine printing his boarding pass was not. That's the difference between 1% of computers and 1% of civilization. And inside each company, Falcon ran everywhere, by policy. The same compliance rule that says every endpoint must be protected guarantees that when protection fails, every endpoint fails. Security software is a monoculture by design. Uniformity is the feature. Uniformity was the blast radius. By mid-morning, CrowdStrike CEO is on television saying a sentence no CEO wants to say. This is not a security incident or cyber attack. We know what it is. We're sorry. And to be fair, the identification was fast. 78 minutes from push to revert is genuinely good incident response. The internet's memory of that day isn't the revert, though. It's IT staff pushing crash carts through airport terminals. Recovery keys read out over the phone, one machine at a time. Delta kept canceling flights for 5 more days. Over 5,000 cancellations. The airline later claimed roughly $500 million in losses, and the lawyers got involved. Insurers put the direct damage to U.S. Fortune 500 companies alone at around $5.5 billion, most of it uninsured. Analysts called it the largest IT outage in history. Think about that phrasing. Not the worst hack, the worst update. And the recovery itself split the world in two. Companies with hands-on IT staff and documented BitLocker keys were mostly back within a day or two. Companies with outsourced IT, thin weekend shifts, or keys locked inside crashed servers measured their recovery in weeks. Same bug, same fix, wildly different outcomes. Preparedness was the only variable. And through all of it, one fact kept resurfacing, almost too neat to believe. Machines that were offline during those 78 minutes, laptops closed for the night, desktops powered down, woke up on Friday completely fine. They'd simply never fetched the file. Whether your company made the news that day came down to a coin flip you didn't know you were flipping. Was your fleet awake between 4:09 and 5:27? So, who wrote the bug? Wrong question. Let's do what the official post-mortem does and count layers instead. Layer 1, a latent mismatch. The sensor's template promised 21 fields, and its integration code delivered 20. Shipped in February, 5 months early. A bomb in the walls. Layer 2, a validator with the same blind spot. It checked content against the spec, not against the sensor as shipped. Your tests can only catch what your model of the system contains. Layer 3, the wildcard mask. Every rule before July said match anything for field 21. So no test, no stress run, and 4 months of production never executed the fatal read. Layer 4, the deployment model. Sensor code rolled out in stages, with customer control. Content went everywhere, at once, within minutes. The safety culture existed. The fast lane just bypassed it. Layer 5, the recovery path. A bootstart kernel driver, plus a poison config file, equals machines that can't be rescued remotely. Nobody had rehearsed that combination. 5 layers, written by different teams in different months, each one locally reasonable, none of them a firing offense. Together, the loudest Friday in computing history. And here's what should keep you up at night. Remove any one of those layers, just one. And July 19th, 2024, a Friday nobody remembers. Validator tests against the real sensor? Caught in February, in a lab. One small canary ring for content? A few hundred crashes, an ugly morning inside CrowdStrike, 0 headlines. Bounds checking on that array read, the rule quietly fails to match. An engineer files a ticket, and the world never learns the number 291. That last one stings the most. The hardening CrowdStrike shipped the following week was, at its heart, exactly that. Check the count before you read. A handful of lines. Since then, field count validation when content is compiled, new tests for non-wildcard cases, staged rollout rings for rapid response content, and customer control over content timing, plus independent code reviews. In other words, the content lane finally got the same respect as the code lane. It took the loudest Friday in IT history to earn it. The bill then, CrowdStrike stock lost over a third of its value in the weeks that followed. Tens of billions of dollars of market value gone. Congress asked its questions that September. A senior executive apologized under oath and walked a committee through channel files and template instances. Probably the most kernel engineering C-SPAN has ever aired. Delta sued. CrowdStrike pushed back, arguing the airline's own aging infrastructure stretched a 2-day outage into 5. The lawyers are still billing. Microsoft convened a security summit at Redmond that September. CrowdStrike and the other endpoint vendors at one table to start designing a future where protection runs outside the kernel. And yet, customers largely stayed. When switching costs are high enough, even a global outage is survivable. That's its own uncomfortable lesson about our industry. So what does any of this mean for you? Because here's the thing. This story was never really about antivirus. It's about every system you and I will ever run. You probably don't ship kernel drivers. Doesn't matter. Swap the words. Your feature flags are channel files. Your schema migrations are template types. Your cron-driven config sync is a rapid response pipeline. First, config is code. If a file can change what your software does, it can crash your software. Test it, canary it, stage it like code. The word just in just a config change is the most expensive word in operations. Knight Capital learned it with a server flag. CrowdStrike learned it with a channel file. Same lesson, 12 years apart. Second, validate against reality, not against the spec. The content validator wasn't broken. Its model of the world was. Contract tests between components exist for exactly this gap. Third, bounds check every read at every boundary, even between your own components, especially between your own components. Inside the walls is where nobody looks. Fourth, your rollback is only as good as a sick machine's ability to receive it. If the failure mode kills connectivity, your remote fix is just a press release. And fifth, rehearse the boring apocalypse. Not the movie plot hack, the bad update. It's the one that actually happens. Those 5 lines cost a code review comment each. The market priced the alternative in billions. If you're enjoying these engineering post-mortems, subscribe. One real story at this depth every week. Now, don't go anywhere, because I owe you one more thing. I told you the update was reverted in 78 minutes. I never told you what those 78 minutes actually looked like. And there's one detail from inside that window that reframes the whole story. The servers that pushed the file, they never crashed. Not even once. Picture the window. 4:09 to 5:27 a.m. UTC. The distribution cloud is perfectly healthy. It has one job: deliver the newest content to every sensor that asks. That's why the push servers themselves never blue-screened. They were distributing the poison, not drinking it. The pipeline's health metrics glowed green while its passengers died. And sensors ask constantly. That's the entire point of rapid response content. Threat intelligence in minutes, not months. So for 78 minutes, a healthy, efficient, well-engineered pipeline delivered a kernel crash to every machine that raised its hand. The better your connectivity, the more diligent your uptime, the more certain your doom. This outage selected for operational excellence. The machines that survived? The ones that were off. The ones on flaky hotel Wi-Fi. The ones somebody forgot to reboot after Patch Tuesday. The stragglers inherited the earth. There's no moral in that, and that's exactly the point. No amount of customer-side diligence would have saved you. The only real defenses lived upstream, in the vendor's pipeline. That's the true inheritance of July 19th. We all run code we can't see, updated on schedules we don't control, with privileges we'd never grant a stranger. Count your own dependencies sometime. The agents on your servers, the auto-updating tools on your laptop. Each one is a fast lane into your machine, and you're trusting someone else's validator. Trust is the operating system underneath the operating system, and trust needs the same engineering as code. Rings, canaries, bounce checks, kill switches. CrowdStrike stages its content updates now. Customers can hold back a version. That 21-field template is probably the most tested object in the company. The next global blue screen won't come from channel file 291. It'll come from whatever field, in whatever file, nobody has read yet. By Monday, most of the world's machines were back. The fix was one file deletion. The recovery was 1 million people, one keyboard at a time. The 40 kilobyte file that started it all now lives in incident response training decks on 5 continents. Channel 291, the most famous config file ever shipped. The blue screens faded into memes, then into slide decks, then into policy. That's how this industry digests catastrophe. Laugh, document, legislate. Somewhere in your stack, a validator trusts a spec instead of reality. A rollout has no rings. A recovery plan quietly assumes the network is up. Find them before your 78 minutes find you. More stories like this every week. If this one earned it, subscribe. Thanks for watching.